Quadratic equations. Algebraic equations are classified based on the highest power of the variable they contain. If you think back to linear equations, y equals mx plus b, the standard form of a linear equation. What's the power of x? If it's nothing there, it's 1. Same for y. So the highest degree in a linear equation is 1. Variables are raised to the first power. How is that different for quadratic equations? The standard form of a quadratic equation is y equals ax squared plus bx plus c, keeping in mind that a, b, and c are coefficients. So what's the highest power in this equation? Well, there's a 1, a 2, and a 1. So quadratic equations are raised to the second degree. Quadratic equations have one variable, and it's raised to the second degree. There are no higher variables. Some examples. Y equals 2x squared plus x plus 3. Would that be linear or quadratic? Well, the degree is squared. There's no higher degree, so this would be a quadratic. Over here, an example would be y equals 2x plus 4. Again, what's the highest degree of the variable? In this case, 1 and 1, so this would be linear. It's very important to know the standard form of the quadratic equation. Again, y equals ax squared plus bx plus c. The a, the b, and the c are the coefficients. Let's do a brain check. Tell us, linear or quadratic? Y equals 3x squared plus 4. Again, look at the degrees. This is a 2, quadratic. Y equals 10 plus 4c. It's like a 1, linear. Y equals 3 plus 14x squared. Again, we see it squared. There's no other degrees, quadratic. Y equals 3x plus 2. 1, linear. What is the standard form of the quadratic equation? Again, y equals ax squared plus bx plus c. Graphs. When you graph a linear equation, it makes a straight line. So you can tell just by looking at the equation whether it's linear or quadratic. Well, if a linear equation makes a straight line, what does a quadratic equation look like on a graph? If you graph a quadratic equation, it creates what's called a parabola. Basically, a U. That's the graph of a quadratic equation. If the coefficient a is positive, then the parabola opens in the up direction. In this case, in front of the x is positive. therefore up. If the a coefficient is negative, the parabola opens in the down direction. So an example, y equals negative x squared plus 3x plus 2. Again, that's not that specific graph, but again, the negative sign in front of the x squared tells you that the graph is going to open up in the down position. Okay, let's review again. What is the standard form of the quadratic equation? Y equals x squared ax squared plus bx plus c. Let's say if these are linear or quadratic. Y equals 4x squared plus 2x plus 3. Again, there's a power of 2, quadratic. Y equals 3x minus 3, linear. Y equals negative 4y plus 2, linear. Y equals negative 7d squared minus 3. Oh, let's raise to the second power, quadratic. If you graph a linear equation, what will it look like? A straight line. If you graph a quadratic equation, what will it look like? Parabola. How can you tell which way a parabola will open? Again, if the coefficient of x squared is positive, it will open up. If the coefficient of x squared is negative, which direction will it open? Down. So let's see if we can tell by looking at these whether they're linear or quadratic. This looks like it facing upward U. That'd be a quadratic. It's a parabola. A downward facing U. Again, still a parabola, so quadratic. And this looks like a straight line. Therefore, this would be linear.